Part A, we're told that P, Q, R and S are points on the circumference of the circle. P, Q, R, S are points on the circumference of the circle, so this is what we call a cyclic quadrilateral. So let's remind ourselves of the circle theorem that involves cyclic quadrilaterals. It's this one, and it says that the opposite angles in a cyclic quadrilateral add up to 180 degrees. So in this case, these two opposite angles must add up to 180. So we can do 180, take away 124, which is just going to be 56. For part B, the diagram shows a circle and a tangent. Here's our tangent. We can see that we've got a chord at that tangent, and that is subtending the angle of 70 degrees. Let's remind ourselves of the circle theorem involved here. It's this one, the alternate segment theorem. We've got a tangent, we've got a chord, and an angle created by that chord. The alternate segment theorem says that those two angles are going to be the same. So angle W is going to be the same as angle 70. And the reason is alternate segment theorem. And then for part C of this question, we've got A, C and D that are points on this circle that has centre O. We're told that BA and BC are tangents to the circle. So if BA and BC are tangents to the circle, let's think about that. What circle theorem can we use here? Well, we know that tangents from the same point are equal in length, which means that these two angles are going to be the same. And we also know that a tangent makes a right angle with the radius. So we can actually use all three of these circle theorems in this case. The other one that's going to be useful for us to remember is that the angle at the centre is twice the angle at the circumference. Excuse me. So, I know that these are equal in length. I know that if that's angle Y, this will also be the same. That will be angle Y as well. I know that this is a right angle. This is a right angle. And the other thing, the angle at the centre is twice the angle at the circumference. So 47 times 2 is 94. Right, notice that this yellow shape here is a quadrilateral. So the angles in this quadrilateral will add up to 360. So the angles in this quadrilateral, I can do 360 minus 94 minus the two right angles. And that's going to tell me what the 2y at the top there is going to be equal to. So this angle here is 86 degrees, so divide that by 2 to work out what y is, and we get 43 degrees.